Hello everyone, my name is Ryan. I'm currently going into my fourth year of undergrad mechanical engineering at UCSB. Here I have an FE prep question for you guys. So the ramp in the figure is rotated until the angle alpha is at 37 degrees, and then the block begins to slide. The coefficient of static friction is most nearly what? So the question here is, what is the coefficient of friction? That's what we want. And we know it's a static problem because, well, it says static and there's really not much going on, and it's talking about the block begins to slide. So when they say begins to slide or about to slide or just about to slide, that's a friction static problem. So let's do some assumptions first. We know that F of F, which is our friction force, would be equal to mu, coefficient of friction, times N, normal force. And for the object to begin to slide, this friction force needs to be less or equal to, friction force needs to be less or equal to the force that's trying to make it slide. In this case, it's the object's weight. So we just need to find our mu here. Okay, so in a static problem or in most engineering problems, we first start with the FBD. Now, of course, during an FE exam, you won't have a lot of time to do this. So, but I want to go through everything so everything is clear and understandable. At the end of this, there's going to be a key formula that you can use right away as long as you know how to get there. So we'll start with the FBD. "37-degree incline," and let's do our forces. We have the weight of the object. I'll say that is mg. And we have the normal force. And the normal force is always going to be perpendicular to the plane it's on, the object is on. So perpendicular, as I've shown there, and I'm going to label this Fn, normal force. And we still have one more force, and that is the friction force. So the friction force is what's stopping the object from sliding. So it's going to be the opposite direction of the slide. So it's going to be that direction. I'll label it as F of F, which is friction force. So one thing I like to do to simplify this problem or make it easier to understand is to rotate the free body diagram. What I mean by that is this. So we have our plane, 37 degrees, and this is our normal force here, perpendicular to our plane, still perpendicular to our plane, and we also have our friction force, which is parallel to our plane. And now we are missing one force, and that's the weight. So what will the weight look like? Well, if you think about it, you're basically just rotating this whole free body diagram 37 degrees that way, this way. And now we only have one force that has an angle. That's our weight. And I believe that makes the problem a lot easier. So we'll go through. In a statics problem, you always want to do your summation of forces or summation of moments, sometimes both. But in this problem, obviously, there's no moment, no relevant moment. And so we're just going to start with our summation of forces in the x direction. And I'm going to say this is our positive direction, that direction. And summation of forces in the x direction equal to 0 because it's statics. So what we can do is start tallying up the forces. So we have our friction force, positive direction, and our weight in the negative direction. Mg sine 37 degrees equals 0. So It's sine 37 because we want the force in this direction. This mg is made up of two forces, one in the x and one in the y. And sine 37, which is the opposite side, we're trying to look for the opposite side of the force, which is this one right here. So now we have, back to our equation, we can substitute our friction force for our assumption previously, which is mu times n equal to, we can move the mg sine 37 to the other side. So that's what our equation's looking at like right now. But what is the normal force? Well, the normal force is not the weight. It's only part of it. So the normal force is this force right here. This force right here. And that's the normal force because normal force is defined as the force that is of the same magnitude and completely opposite direction of the normal force. So what is that force? I'll write it over here. N equals mg, and it's the adjacent side of the angle. So adjacent is cosine 37 degrees. And we can plug that in to our main equation. So mu times mg, cosine 37 equal to mg sine 37. Now it's gonna look really familiar now. Now you'll probably get an idea of where we're going with this. So we can solve for our mu here. We can just cancel out mg and solve for mu sine 37 over cosine 37. And you'll look at this and see, wow, that's super familiar. Sine over cosine. What is that? That is actually just tangent 37 degrees. And that is our key formula here, tangent 37 degrees. So when you run across a problem like this, you can think about the angles, and if it makes sense in your mind using this explanation, then you could just skip to this formula. But you have to make sure that it makes sense because they might ask for a different thing. So that's why I wanted to go through this one by one or slowly. So mu equals tangent 37, which is just 0.75. And that is our answer. Let's see if that's one of the choices. If it's not one of the choices, let's just pick the closest one. There we go. 0.754. So the answer to this question is C. Thank you for watching. I hope I have been helpful, and leave a comment if you have any more questions.